Radar is very important in automotive sensors, but these days we don't just have one, and they're not just simple range sensors. Can you tell us about the latest SAF86 and how you've been using it at NXP?
Good question, Bill. So what we introduced this year at CES is the SAF8600, which is an extension of our 28 nanometer radar single chip family, which is not focusing as much on individual sensors like we had in the past, but focusing on a network of connected sensors where we have 5 sensors on the mid-range vehicle, 10 sensors on the premium vehicle by 2025. So going forward, these sensors will be connected, they will be adaptable, they will be upgradable, supporting advanced comfort functions like the highway pilot, like the traffic jam assist, the automated park assist, or the urban pilot. So it's a very, very pronounced shift. So in a sense, the new product is targeting software-defined vehicle architectures. And in software-defined vehicle architectures, we can add on premium radar sensor hardware capability software-defined features that will evolve over time. What we are showing here is our system solution for radar and software-defined vehicles, which in the example is delivering us a 360-degree radar sensor data fusion, which takes the data from the sensors equipped with the SAF8600 mounted around the vehicle, transfers that data, detail-rich data, range FFT data through a wide bandwidth gigabit Ethernet interface towards our radar controller that sits inside the ADAS ECU of the vehicle, where we take the data from the sensors and fuse it together for a 360-degree point cloud. So here we are showing another example of connected radar sensors and what new possibilities they actually provide in a setup together with our partner Sendar, where we use data from multiple sensors that are observing the same object and are combining that data coherently to improve the sensor resolution. Technically speaking, sensor resolution is proportional to the sensor's aperture or antenna size, but practically the sensor antennas cannot grow too much for integration reasons, since the sensor needs to fit behind the bumper in front of the vehicle. So this approach, where we are taking these small form factor sensors and separate them physically, creates a physical aperture that is larger than the individual sensor's aperture, allowing us to achieve sensor resolution improvement of up to 10 times. And what that does for us, we can illustrate here very impressively, where we have a scene where 2 pedestrians close to each other are walking away from the sensor, and as they walk away, we observe whether we can still separate the 2 pedestrians, and we see that 100 meters distance, they are still clearly separated, and they keep walking away, and all the way up until 240, 250 meters, 2 pedestrians can still be separated very reliably. This is a direct result, on the one hand, of the 28 nanometer RFCMOS we are using on our radar single chip, combined with a distributed aperture radar approach, which our partner company Sendar is demonstrating here.